Okay, if I give you that f of x is 3x plus 5, and you were to find f of 4, then you just plug 4 in for x. So this would be 3 times 4, which is 12, plus 5 is 17. If I give you another variable, like f of a, you just plug a in for x. So this just becomes 3a plus 5. If I give you a plus 2, that whole thing needs to go in place of the x. So you'll have 3 parentheses a plus 2 plus 5, and then you will distribute to simplify. Plus 6 plus 5 is going to give you plus 11. If you're given the graph of a function, you can calculate the value of f of 4 by just looking at the x value of 4, which is right here, and the y value is 0. So we say f of 4 equals 0. F of 7 is also 0, because if you look at the x value of 7, you get 0. If we look at f of 0, right here, x equals 0, the y value is about 5.1. If we look at f of 2, x equals 2, it looks like y equals 3. Remember that if I say f of 2 equals 3, that means the ordered pair 2, 3 is on the graph. Here we have another example of just plugging a value in for a function. So f of 5 would be 5 squared plus 5, which would be 30. F of m would just be m squared plus m. But when you have something like m plus 1, and you have x squared and x, it's a little bit more complicated. So you're going to have m plus 1 squared plus m plus 1. You will need to simplify this by foiling m plus 1 squared, which gives you m squared plus 2m plus 1, and you still have the m plus 1. Altogether, you would get m squared plus 3m plus 2. If you have the equation and the graph, you can kind of look at both of them to support your answer. If I plug in 1 to the equation, I get 1 plus 1, which is 2. If I plug in 0, I get 0 plus 0, which is 0. If I plug in negative 3, I get 9 plus a negative 3, which is 6. Then if you come over and look at the graph, the point 1, 2 is on the graph right here. There's the point 1, 2. 0, 0 is also on the graph, and the point negative 3, 6 is on the graph. So you can look at the graph, or you can plug the values into the equation.